Hello, good morning everyone. In this episode, we were going to be talking about AC circuit under the topic phasors. So let's define first a phasor. A phasor is a complex number that represents the amplitude and phase of a sinusoid. So let's now go into the problem. So we have to find the steady state values of I and V given this circuit. So as you can see, the voltage source here, Vs, denoted Vs, is in sinusoidal form. So we will gonna transform that into polar form. So we have here the amplitude 4, angle. The sinusoidal function has no angle, so therefore it is 0 degrees. The next one is we will gonna put also its angular frequency. This one, 2500, denoted by omega. 2500. So after that, we will gonna be transforming these inductors and capacitors into resistors by solving it and treating them as resistor using the impedance. So impedance is a circuit ratio of the phasor voltage V to the phasor current I measured in ohms. So it is measured in ohms, therefore we can consider them as resistor. So but for that we will gonna follow its equation. So for the inductor, we have the Z impedance is equal to J omega L. By the way, this J is just an complex constant. So this is for the inductor. And for the capacitor, to make them as resistor, we have Z is equal to 1 over JWC. This one is for the capacitor. So now we know their equations. So we will gonna solve first the inductor. So we will gonna make this as the first inductor, ZL1, ZL2, and the ZL3. So we have ZL1, which is equal to this equation, no? So omega 2500, this is the J, the complex constant I, and the value of the L inductor, 10 millihertz. So we will gonna calculate it. So before you can calculate this problem, you have to first set your calculator into this one mode, then set to complex, and then you can just calculate this. So 2500 I times 10 times 10 to the power of negative 3, we have 25I. 25I ohms. That's for the value of the first inductor. So for the second inductor, ZL2, we have 2500I times 40 millihertz. 40 millihertz. So we have 100I. 100I ohms. And for the last inductor, ZL3, we have 2500I times 20 millihertz, and that value would be 50I. Now we already obtained the value for the inductor. We will now go to these two capacitors. So this one will be ZC1 and this ZC2, 1 and 2. So for the ZC1, we will gonna use this equation, 1 over 2500I times the capacitor 8 microfarad. So 1 over 2500 I times 8 times 10 to the power of negative 6. We have negative 50I. For the second capacitor, we have 1 over 2500 I times 2 microfarad. So we have the value of negative 200I. So after obtaining its impedance form, so we have now it is in ohms. So we will gonna find its total impedance, the ZEQ. So we're gonna write here. So as you can see, this inductor and this capacitor are in series, so they are already now in resistor form. So we can do this. These two can be series. So as resistors in series circuit, we can just add them the value of the ZL, what's this, ZL3. So we have 50I. No, alright. ZL3 plus the ZC2. ZC2. So the value for ZL3 is 50I. 50I plus this ZC2 negative 200I. And now we can just 50I minus 200I. We have negative 150I. So negative 150I for this part series. The next part is this. Right. This one we can also series that. So we can just add it again. So this one is the ZL2 and the ZC1. ZL2 plus ZC1 is equal to, the value for ZC2 is 100I minus ZC1 minus 50I. So we have 50I. Now you imagine that these two series are already combined. We can perform parallel to that. So these two obtained values, we can do it parallel. So the same as resistors, we can just use the equation when it's in parallel. So in parallel form, resistor is 150I times 50I over negative 150I plus 50I. So we have negative 150I times 50I over negative 150I plus 50I. We have 75I for that parallel. Now we have already combined that, so the combination of these two, we can just series into this value, the 10 millihertz, to obtain the ZEQ. So 75I plus the ZL1 25I. So we have the value of the ZEQ, which is equal to 100I. But it will not end to that. So because we will gonna, after that we will gonna find the I using the equation of the Ohm's law, but in phasor form. So we will gonna put some scratch here. So here, to find that, we will gonna draw again the circuit. This is the resistor form. Let's just imagine it as resistor. So ZEQ, the current I flowing, and the Vs, which is the value of 4 angle 0. So to obtain I, it's Ohm's law that I is equal to V over R. But we have in the phasor form V is equal to ZEQ. So we have 4 angle 0 over the obtained value earlier, the ZEQ, which is 100I. So we can obtain that value for 4 angle 0 over 100I. So we have negative 0.04I. Now this form is in rectangular. We can also make it on a polar form. After you obtain the value, you can just press shift 2, then this one, this angle. So this is the polar form. So we have 0.04 angle negative 90 degrees ampere. So this is already the current I. So after we have obtained the I, so we will now go to the V. So V is equal to, just like in the Ohm's law, V is equal to I times ZEQ. So we can just multiply it, negative 0.04 I times the ZEQ 100I. So we have negative 0.04 I times 100I. We have the value of the V, 4 volts. And that's the last value to be obtained. So as you can see, the 4 volts is just same as this voltage source for angle 0. So that's for today. Thank you and hope you learned something.